Finding the equation of parabola with given focus in Directrix. For example, we have here the graph of the parabola, and the focus is at this point P, which is 0 and P, the focus, and the distance from the focus to the vertex is we can denote with a P, so this is distance. The directrix is an opposite side of the focus, which is at the same distance. Here is a P, with the distance P. Whatever is distance from the vertex to the focus, the same distance is from the vertex to the directrix. And directrix is equal with minus P. So this line here. And now, if we are taking a point, a distance between the point P and any point in the graph, any point, xy, and then we take from this point of the graph and the perpendicular to the x-axis or a directrix, a distance up to the directrix, those two distances are equal with each other. Doesn't matter where I'm taking. Either we are taking here this distance from P to this point here, and from this point perpendicularly to the directrix, those two distances are going to be the same distance. It doesn't matter where we are taking. So this is a sum of the properties of the equation of the parabola with a given focus and a directrix. So now let us try to find a formula equation for the parabola with a given focus and directrix. For example, we have this situation here. If we have this situation here, it is the focus with a point 0 and P. So just let me take a pen here. And at any point in the graph is x and y. We have this point here. So from this point up to the directrix, we have another point, which is x is the same because it's a perpendicular. It means this is a x. So this is one point, and the other point is the distance minus p. So it's a distance minus p here. So because from here to here is minus p. And now we are trying to make this is, let's say, distance 1, d1, and this is a distance d2. Because here in the graph are shown those distances because are the same, they denoted with the same denotation d. And now, according to the distance formula, d1 is going to be equal with the square root of x2 minus x1 squared plus y1 or y2 minus y1 squared. So we are just taking, because it's not very straight, let me make a little better. So what we have here. So now we taking this distance. This distance is x is a 0 minus x, or x minus 0. So it doesn't matter which way we are going. x2 minus x1 or x1 minus x2 is either way. So x minus 0. I think it looks much better. X minus 0 than 0 minus x, but it's the same distance, so it doesn't make any difference. Therefore, I'm writing x minus 0. And now I am taking for the y's, and y is y minus p, since I'm going in this direction. Y minus p. Y minus p squared. So already for d1 we got this distance squared. I'm sorry, here is d2. Let me denote d2. d2 and d1, because we denoted here d1, therefore I'm taking this distance from here to here now. The d1 is going to be equal, again I'm taking the same formula for the distance, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And in this case I'm taking x minus x. So it's x minus x squared. X minus x squared, which is going to be 0. So this is very obvious. Plus, and here I have y, minus is the sign of the formula, and the minus here is going to be y plus p square. And now we are taking, because distance 1 we already had here in the beginning, because d1 is equal with d2, and of course these distances are equal, so I'm taking now d1 is equal with d2. And if I'm squaring both sides, I can take a d1 square is equal with d2 square. With d2 square. And now d1 square, let me take x minus x is equal with 0. So this is 0. We already know. This is going to be here 0. This is going to be 0. So I'm taking d1. I have just y plus p squared. Because if I'm squaring everything d1, the square root is going to disappear, because this index via the square is going to disappear. So I'm taking just y plus p square, everything is in square, is equal with d2, I have x minus 0 square. X minus 0 is x square. X minus 0 is x, and because it's a square is x square, and is a plus y minus p square. And this is a binomial is in the square. We can use it just like a formula: a plus b squared is equal to a plus 2ab plus b squared. But in this case we have y is a y square plus 2py 2yp or 2yp, let me write, either way is 2yp plus p squared. P squared is equal. So with the left side I'm done. I'm going with the right side. Is x squared. Again I have the algebraic formula: y minus p squared is equal to the plus y squared. Y squared minus 2yp plus p squared. And everything I am going to subtract by y squared minus p squared. Minus y squared minus p squared. And if I'm going everything to subtract, here minus y squared minus y squared minus p squared minus p squared. So everything here I can cancel. So those I can cancel. I can cancel those terms. And now I'm looking what remains here. 2y, I have here 2yp is equal with a minus 2yp plus x squared. You see I have x squared here, and I have a minus 2yp plus x squared. And now both sides I am adding plus 2yp, both sides, 2yp And if I'm adding both sides 2yp, here is going to be 2yp, and I'm adding here 2yp. So now I can cancel those same terms. So this same term I can cancel here, and this here. And what remains here? Here remains the x squared, so I will write x squared on this side, x squared, and the other side I'm going to make a 4py. So I got the equation for the parabola with a given a focus and the directrix.